Hi, today we are going to continue with the response of second order system. Previous slide we have gone through undamped as well as underdamped. Today we are going to see about critical damped as well as overdamped of a second order system. So before entering into the topic, we should know the closed loop transfer function of a second order system. The closed loop transfer function is C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. I already told you all the four cases you have to use the same transfer function. Only difference is zeta value will vary. Previously we have seen zeta is equal to 0 for undamped and 0 less than zeta less than 1 for underdamped. Now critically damped zeta value is 1. So substitute 1 for zeta in the above equation so that you will get as C of s by R of s is equal to omega n square divided by s square plus 2 omega n s plus omega n square, which can be modified as omega n square divided by s plus omega n the whole square. And you know that we are studying the second order system with respect to unit step. So unit step means R of t is equal to 1. Therefore, in terms of Laplace, it will become R of s is equal to 1 by s. So the response can be written in s domain. C of s is equal to R of s into omega n square divided by s plus omega n square, which is equal to 1 by s into omega n square divided by s plus omega n square. Now you know that after this you have to go for applying the partial fraction equation. Then only we can find the value of C of t. So partial fraction expansion, we have to write the equation, and by writing we will get it as a by s plus b by s plus omega n the whole square plus c by s plus omega n. And we have to find the value of a, b and c. Now a, how you will find in the sense, you have to multiply s with c of s and let s is equal to 0. So that you will get the value as omega n square divided by s plus omega n this n omega s plus omega n the whole square, letting s is equal to 0. So when you substitute s equal to 0, you will get it as omega n square divided by omega n square, which is equal to 1. Now we have to find what is b. When you are finding out b, you have to multiply c of s with s plus omega n the whole square and letting s is equal to minus omega n. Once you substitute, you will get b value as minus omega n. Now we have to find out c. When you are finding out c, you have to find out, first you have to differentiate the s plus omega n the whole square, and then it has to multiply with c of s and letting s is equal to minus omega n. So once you go for differentiation and letting s is equal to minus omega n, you will get the value of c as minus 1. So you got the expansion as c of s is equal to 1 by s minus omega n by s plus omega n the whole square minus 1 by s plus omega n. So we have, this is the equation which you have got in Laplace transform. Now we have to write in terms of t domain, time domain, that is c of t. How can you find c of t? In the sense, you have to take the inverse Laplace transform of the s domain, that is L inverse of c of s. Once you take L inverse, it will become L inverse of 1 by s minus omega n by s plus omega n the whole square minus 1 by s plus omega n. We have standard equation for all those things. L of 1 is equal to 1 by s. L of t into e power minus at is 1 by s plus a square, and L of e power minus at is 1 by s plus a. So once you use this standard equations, you can get the expression of c of t as 1 minus omega n t into e power minus omega n t minus e power minus omega n t. So that once you take e power omega n t outside, you will get c of t is equal to 1 minus e power minus omega n t into 1 plus omega n t. So just glance of the above equation. For a closed loop critically damped second order system, if it is a unit step response, the equation is 1 minus e power minus omega n t into 1 plus omega n t. And if it is a step response, the above equation has to be multiplied with a. You can see the response over here. You have given input as unit step and you will get a response, and this response is nothing but the response which you got for a critically damped second order system. Now we will see overdamped. Same thing what you have discussed already. C of s by R of s you have to consider, which is nothing but omega n square divided by s square plus 2 zeta omega ns plus omega n square. And we know that for overdamped, zeta is greater than 1. And hence the roots of the denominator of transfer function are real and distinct. Let the roots be SA and SB, or else sometimes it may be represented as S1 and S2. So roots we have already identified in the previous slide. It is minus zeta omega n plus or minus omega n into root of zeta square minus 1. So we have to take in terms of two roots. One is SA and SB. So we'll take it as S1 is equal to minus S2 and S2 is equal to minus SB. So you'll get S1 is equal to zeta omega n minus omega n into root of zeta square minus 1, and S2 is equal to zeta omega n plus omega n into root of zeta square minus 1. So now you have to do partial fraction. You can see the equation over here. C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega n plus omega n square can be written as, in terms of S1 and S2, it can be written as omega n square divided by s into omega n square divided by s plus s1 into s plus s2. Now we are considering unit step. So R of t will be equal to 1 and hence R of s will be equal to 1 by s. So C of s can be found as R of s into omega n square divided by s plus s1 into s plus s2. So the equation can be rewritten as omega n square divided by s into s plus s1 into s plus s2. You have to apply partial fraction now. So you will get C of s is equal to a by s plus b by s plus s1 plus c by s plus s2. Previously also you have found the value of a, b, c. Same thing you have to do here also. So a can be found as when you are substituting or multiplying C of s into s, letting s is equal to 0, you can get a value. Once you do like that, you will get value as omega n square divided by s1 into s2. Similarly, we have to go for b and c. So we can still simplify it because we have already taken s1 and s2 value. Substitute over here s1 and s2, and then you are substituting it over there. You will get it as omega n square divided by omega n square, which will be equal to 1. Similarly, you can find b also. In that b, you have to take the value as s plus s1, which has to be multiplied with C of s and letting s is equal to minus s1. Once you do like that, you will get the equation as omega n square divided by minus s1 into minus s1 plus s2. Now what you have to do in this is, you already know the value of s1 and s2. Substitute over here and then simplify it. Once you simplify, you will get it as minus omega n divided by 2 into root of zeta square minus 1 into 1 by s1. Now you have to find what is C value. If you have to find the C value, you have to do the same thing at what you have done previously. C of s into s plus s2, letting s is equal to minus s2. So once you substitute like this, and when you simplify, you will get it as omega n divided by 2 into root of zeta square minus 1 into 1 by s2. You can see b value is minus of that value and c is plus. You can see both the equations are same. Only thing is plus and minus variation is there. Now you substitute all those things in your C of s equation and find what is C of t. If you have to find out C of t, you have to take L inverse of C of s. I have not written it here as we have done all those things similar. I have directly jumped into the time domain equation. C of t is equal to L inverse of 1 by s minus omega n into omega n divided by 2 into root of zeta square minus 1 into 1 by s1 into 1 by s plus s1 plus omega n divided by 2 into root of zeta square minus 1 into 1 by s2 into 1 by s plus s2. Equation you have substituted. Now we have to go for finding out the value. Once you find out the value, you will get C of t as 1 minus omega n divided by 2 into root of zeta square minus 1 into 1 by s1 into e power minus s1 into t, plus omega n divided by 2 into root of zeta square minus 1 into 1 by s2 e power minus s2 into t. Once we simplify this, you will get equation as 1 minus omega n into root of zeta square minus 1, because it is common for both the terms. Remaining is e power minus s1t divided by s1 minus e power minus s2 divided by s2, where s1 and s2 already you have declared zeta omega n minus omega n into root of zeta square minus 1, and s2 is zeta omega n plus omega n into root of zeta square minus 1. So you got the Laplace equation. So same thing we have going for a glance over here. Now unit step response means 1 minus omega n divided by 2 into root of zeta square minus 1 into 1 by s1 into e power minus st divided by s1 minus e power minus s2 divided by s2. And if it is step response, you have to multiply it with a value. So you have seen already the equation with respect to unit step and step response. If it is a step response, it has to be multiplied with a, otherwise the equation is as such only. Though we can see the waveform over here, unit step input you are giving and the response which you are getting is varying with respect to zeta values. We know that zeta is greater than 1, so you can take any value of zeta and it will get the corresponding waveform over here. So by this we are finishing all the conditions for zeta equal to 0, zeta greater than 1, zeta less than 1, as well as zeta equal to 1. All the conditions we have finished. Next topic will be considering time domain specifications. Thank you.